In this problem, we're going to be looking at the directional derivative. Now, before beginning this video, I highly suggest you go back and look at some other previous ones on partial differentiation, and also looking at the gradient. You can see here that we've been given xy cosh x plus 2y at the points 1 and minus a half and is equal to 0. This is kind of all the information we need, and maybe they'll ask you what direction it's going in, or something of the equivalence. There are a few equations that you need to know, and you need to just remember them. But before I begin this, I also want to point out that you should definitely go over your lecture notes. As previously stated, this is a problem-based learning channel, so by going through this, it's just cementing your knowledge. So to begin something like this, the first thing that you need to do is find out the gradient of fxy, which would look like something like this. So we're going to have to differentiate this in terms of x and differentiate this in terms of y. Unfortunately, there's an xy cosh x plus 2y, so that means we have to do the product rule for in terms of df dx, and we have to do the product rule in terms of df dy. So I'm going to quickly go through that. So du dx will be y, and v is cosh x plus 2y, so that means dv over dx would literally be sine h x plus 2y. If you're a little bit lost as to what I've done, like I've said, go to the product rule. You should know this by now. You should know how to differentiate all of this. So then that means that is my df dx. And we can do df dy now. So same as here, u and v. So du over dy will be x, and dv over dy will be 2. Sorry, where am I looking? Here, 2 sine h x plus 2y. Therefore, u dv dy will be 2xy sine h x plus 2y plus v du dy, which is x cosh x plus 2y. So now we have df dy and dx dy. What we now have to do is begin by if we just, I'm not going to rewrite it all again. This goes here, this goes here. But we've been given the points 1 and minus a half. So this implies that we're looking at the coordinate points. So if you get a whole number, a number, sorry, it could be a decimal, whatever, as long as you get 2 points. So I'm now going to plug in, if I plug in 1 minus a half sine h, 1 plus 2 times minus a half, and so on into here, that means my nabla of f, plugging in 1 minus a half. So if I plug this all in, if you follow this through, if I do 1 here, blah, 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 I should get minus a half as my df dx, and then if I plug in 1 and minus a half into this, you should get 1. So now this is that's the easy part, I suppose. Now this is something that might be new for you. You've got to remember it. So now I'm going to say here, I'm going to let u equal alpha and beta. You could pick whatever, any Greek letter, like, it doesn't really matter. And this is going to be a unit vector. Such that alpha squared plus beta squared will equal 1. This is something that you need to know. You must remember this because we're going to now use this into manipulating the answer. We're going to get a simultaneous equation. We're going to plug it into here, manipulate it around, and get a value for beta and a value for alpha. And also the directional vector of f at 1 and minus a half multiplied by u, the unit vector, will equal minus a half 1 multiplied by alpha beta, which equals 0. So this means you are now going to take essentially this is actually wrong. Don't this is not correct, but this is the way I try and remember it. Is alpha and beta equals 0. But we know that alpha is minus a half and beta is 1. So minus alpha plus beta equals 0. So this means that beta equals half alpha. Therefore, alpha equals 2 beta. Just rearrange that simply. And now I have this. So what you must do is just get alpha plus beta equals 0. Get that equation. Plug in what you've found here into this. So you've got minus a half alpha plus beta equals 0. You've rearranged it and you've got something. And now you go back to this equation here. I know that alpha is 2 beta. So why don't I just plug this back in? So now I'm going to get 4 beta squared plus beta squared equals 1. So this is obviously 5 beta squared, which equals 1. Beta squared equals plus minus... Oh, whoops, let's just do beta equals... I kind of skipped a step there. So I'll just rearrange this, divided both sides by 5, and then square rooted it. So I get plus minus, because obviously it's just squared. So now I know what beta is. You plug it in, you can find out what alpha is. But this is... how to find out a problem like this. You might be given a problem which might be multiple choice. It could be a larger question, but it would say the directional derivative of the function f of xy equals xy cosh x plus 2y at the point 1 and minus half is equal to 0, and it might say which of the following in which of the following direction or directions. So you'd be given maybe a series of solutions, but now that you know that it's plus and minus root 1 over 5, you can then plug in plus the positive of this into here, and then you can plug in the negative of this into here and get your values for alpha, and then you now know the directions in which it is going.